Section 2.1, Properties of Linear Functions and Linear Models. In this section, you'll see a lot of overlap in material that we've already gone over in Section 1.3. If, for example, we start with increasing, decreasing functions, and that's something that you've already seen. If you recall, the slope of a line is blank, then the function is increasing. If you said positive, then you are correct. So if the slope of a line is positive, then the function is increasing. If the slope of the line is negative, then the function is decreasing. We also went over rate of change. We said that the rate of change of a line is just the slope. When we don't have a line, if we have another type of function like a parabola, then we just take the secant line, the slope of the secant line. But in this case, we're only doing linear functions. And so the rate of change is the slope of the line. And you already know the formula for this. It is the change of y over the change of x, or you're more familiar with the formula y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Because we are dealing with functions, instead of writing y sub 2, we are going to write f of x sub 2, which is another way to write y sub 2. And instead of y sub 1, we are going to write f of x sub 1. Notice that I box this in red, and I always tell you in class that things that I box in red are formulas you do have to memorize for the test. So please memorize this. And I know our class went virtual because of the coronavirus, but we are still taking exams in class, and you will need to know this formula. Okay, so just so you know what the definition is talking about. So we divide the output by the input. This formula, we already talked about this. So this formula should remind you of the slope formula. For example, for linear equations, the average rate of change of f of x equals 7x minus 3 is what? Well, recall that a linear equation has this form where m is the slope. Okay, and we said that the slope is the rate of change. Therefore, the slope of this function is 7, and hence 7 is the rate of change. Only linear equations have a constant rate of change because their blank is constant. Their slope is constant. Based on this, the average rate of change can be used to determine whether a function is linear. So if your rate of change is constant, then you have a linear function. For example, the average price for a ticket to a movie theater in North America for selected years is shown in the table below. Find the average rate of change of ticket price with respect to time over the period. Oh, that should say 1999. Sorry about that. That's a typo. Make sure you change it in your lecture notes. That should be, and I'm looking at this year. Not the year 199, but the year 1999. Okay, so I'm just going to highlight where on our table is that. So here's 1987. That's our input. And here is our output for 1987. Here's our input, 1999. And here is our output. Okay. Let's go ahead and do this problem. Change of price You can think of that as your Y values over the change in year. And by the way, a note, remember I say how the note will always help you with respects to, tells you what your input is. So since we're doing this with respects to time over the period 1987 to 1999, then I know time is our input. Okay. So we have 5.06 minus 3.91, our output, all over 1999 minus 1987. And that gives us 1.15 divided by 12. Okay, so that's a weird answer. We can't have a decimal and a fraction. I did put it in my calculator and we got 0.0958. But what does this mean? What does it actually mean? I don't want you to just get answers and not think about what they mean. When you think about what an answer means, then you will know if it makes sense or not. If it doesn't make sense, then you probably did something wrong. So notice that our average rate of change is price per year. So this here, this number 0.0958, that is our price per year. Because there's nothing underneath, I'm just going to put an imaginary 1 just so you know what this means. So if I were to actually write in a sentence what this means, I would write every year the price of theater tickets increases by, now because we're dealing with money, I'm not going to write 0.0958. I'm going to round this to the nearest cent. That is 10 cents. So every year the price of theater tickets increases by 10 cents. And I will write on test to interpret your answers verbally so you know exactly what you are looking for. Okay. Example 2. I think I'll stop here just so I can upload the video and then I will continue in the second part.